functions reduced to quadratic form. Now, our approach is basically going to be something called U substitution, where we make an appropriate substitution to reduce the quadratic form from just using a different variable. Okay, and then basically once we make that substitution and we simplify it down to a quadratic equation, we'll solve that resulting quadratic equation, and then once that quadratic equation is solved, we'll take the results from it and plug it back into our U substituted variable there and solve for the original variable. Okay, so let's look at this first example. Now, it says x to the fourth power minus 12x squared minus 3 equals 0. What you can notice here is this is a very, very similar setup to what we would see in a quadratic. In a quadratic, we'd have ax squared plus bx plus c equals 0, right? Now, if we're looking at this, here we have an x to the fourth and here we have an x squared. So we're doing a step down by a factor of 2, just like we do here. We go from a squared to a basically factor of 1 there. So technically, if we decided to let x to the fourth equal, say, a variable u squared, what we could do is we could substitute u squared in for our x. So it would look like, in our new formula, it would look like u squared minus 12u minus 3 equals 0. Because if x to the fourth equals u squared, that means that x squared has to equal u, right? So we're able to substitute in u squared for x to the fourth and u for x squared. Now we have a resulting quadratic equation, u squared minus 12u minus 3 equals 0. Now we can solve that resulting quadratic equation. What we will start it by is factoring, if possible. Okay. Now, if we look at this one, it's not able to be easily factored here because I don't have two factors of 3 that wind up adding to 12, or negative 3 that add to negative 12. So you've got a couple of things you can do. You can complete this square like we did last time. You can plug it in the quadratic equation if you'd like. The quadratic equation, negative b plus or minus the square root of b squared minus 4ac all over 2a works perfectly fine here, with our a being the 1, the b being the negative 12, and the c being the negative 3. Okay, well that's going to give us negative 12 plus or minus the square root of negative 12 squared minus 4 times 1 times negative 3 all over 2 times a in this case is 1, and then we can just simplify from there. So negative 12 is 12 plus or minus the square root. Negative 12 squared is 144. Negative 4 times 1 times negative 3 is positive 12, and this is all over 2. Continue to simplify here. This is 12 plus or minus the square root of 100 and 156 all over 2. Okay, now we need to look at that square root of 156 and see what we can break that into to try to simplify. So let's see, 156, 12 will go into that 13 times, but 12 is not a perfect square root, but 4 is. So 156 divided by 4 would be 39. That makes sense. So we could technically break this into 12 plus or minus the square root of 4 times 39 all over 2, which should simplify down to 12 plus or minus 2 square root 39 over 2. which finally simplifies down to 6 plus or minus the square root of 39. All right, so we've gotten that far. We have our two solutions. One of them 6 plus the square root of 39, one of them 6 minus the square root of 39. But we're not done. We need to take this solution and recognize that that is equal to u. That is equal to mercy me. That is equal to x squared, right? And the reason that that's equal to x squared is because it's technically equal to u. Because when we come through here, what we had was an equation that we essentially solved for u. So if this is technically equal to u equals 6 plus or minus the square root of 39, and we know that u equals x squared, sure, that means that x squared has to equal 6 plus or minus the square root of 39, right? Which technically means that x equals plus or minus the square root of 6 plus or minus the square root of 39. Really fun, right? Now, technically, this is 4 distinct solutions. However, 2 of them wind up being imaginary. Okay? Because if you look at the square root of 39, the square root of 39 is technically bigger than 6, but not quite 7. So if I'm subtracting the square root of 39 from 6, I'm winding up getting a negative number in my square root, my biggest square root here, which is going to give you an imaginary number. So technically, you would have 4 solutions here if you were okay with the imaginary solutions. You would have the square root of 6 plus the square root of 39. You would have the square root of 6 minus the square root of 39, which would give you an imaginary solution. You would wind up having negative square root of 6 plus the square root of 39. And you would have negative square root of 6 minus the square root of 39, which would also give you an imaginary solution. So 4 solutions in this individual case. Let's try this one. All right, here we have 4x plus 5 squared plus 24 times 4x plus 5 plus 144 equals 0. Now, what we want to do first, this has the form of a quadratic. We just need to do the substitution, right? Because if we put a u here and a u here, we could wind up with a substitution where basically 4x plus 5 equals our u, so that our overall equation looks like u squared plus 24u plus 144 equals 0. Okay, then we can solve the resulting equation. Okay, so if I factor this, should be able to factor this one. This one should actually be a fairly easy factor. I need 2 things that multiply to give me 144 and add to give me 24. How about 12? Okay, so 12 times 12 is 144, and 12 plus 12 is 24, so that works out nice, and they're both the same. Since they're both the same, if I was to solve this, I would have to set both of them equal to 0, which is truly just a single solve here, so that u equals negative 12 in both cases, right? But remember, we're not done, because we were trying to solve for x, so we have to resubstitute in for u. 4x plus 5 is what equals u, so 4x plus 5 then must equal negative 12, and I can now solve for my x. So I can subtract 5. It's going to give us 4x equals negative 17. I can divide by 4 and get that x equals negative 17 fourths. Just a single solution in this particular scenario. Now let's look at this one. How about x squared plus 4x all squared minus 10 times x squared plus 4x minus 39 equals 0. Hopefully at this point, the u substitution just starts to jump out at you. So here I'm going to let u equal x squared plus 4x. Okay, easy enough. That makes that be a u squared minus 10u minus 39 equals 0. Well, now I need to look and see if I can get two factors of 39 so that I can make this easily factorable. Those two factors need to add to give me negative 10. Well, how about negative 13 and positive 3? This, by the way, you should have learned factoring in Math 108, which is a prerequisite for this course. And if you decided to skip Math 108 and come directly into this course because you scored high enough, that means we assume that you know how to factor. If you're having trouble with factoring, I highly recommend looking up some videos to help you with factoring, because we assume that you know how to factor quite well at this point. All right, back to the problem here. So like I said, if you work this backwards, u times u is u squared, u and 3 and negative 13 and u give us the negative 10, and then negative 13 times 3 gives us the negative 39. All right, now we have two things that we can set equal to 0. We can set u minus 13 equal to 0 and u plus 3 equal to 0. Solving is something you should also be very good at too, because you already passed the Math 108 course. So here we have that u equals 13 and u equals negative 3. But we're not done, right? Because we're not trying to solve for u, we're trying to solve for x, which means we need to substitute the u part back into this equation. Well, that's x squared plus 4x equals 13. And here, when I substitute it over here, it's x squared plus 4x equals negative 3. Now I'm going to start with the one over here on the left. We're going to solve it, and we'll come back and solve this one over here on the right. What I'm going to do is I'm going to bring the 13 over here to the left-hand side by subtracting it over. So I get x squared plus 4x minus 13 equals 0. Then my goal is going to be to try to factor it. Now, I'm going to have an issue here, right? Okay, because I need two factors of negative 13 that add to give me 4. Man. Can I make it happen? Can I factor it? Don't think so, because the only factors of 13 are 1 and 13, and you can't combine a 1 and a 13 to get you a 4. So factoring gets out of the realm of possibilities here. Now you can complete the square and solve it from this point if you want to, or you can use the quadratic equation. I'm going with the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that I'm looking at negative 4 plus or minus the square root of 4 squared minus 4 times a times c all over 2 times a, which is 1. Now we just get to simplify. 4 plus or minus 4 squared is 16. Negative 4 and 13 give you a positive, let's see, 4 times 13. Ooh, ain't done that one in a while. That's what, 52? 4 times 3, 12. All right, all over 2. Let's see if we can simplify it anymore here. Let's see, 16. 16 plus 52 is what, 68 all over 2. 68. Can I break 68 down into anything nice? I think I can break it down into a 4 and a something. Let's see, how many times 4 go into 68? Have a calculator, you figure it out. 17 times. So yes, I can break this down into negative 4 plus or minus 4 times 17 all over 2, which breaks down to give me negative 4 plus or minus 2 square root 17 over 2, which gives me negative 2 plus or minus the square root of 17. Now those are two solutions, right? Just from that left-hand side of the equation. We still have this right-hand side of the equation to try to figure out. Let's see what we can do with it. It should at least be a little easier, because if I move the 3 over here, it should now be easily factorable into x plus 3 and x plus 1, which is going to render out our other two solutions very, very quickly. We get an x equals negative 3 and an x equals negative 1. So now we have four solutions. X equals -3, x equals -1, x equals -2 plus the square root of 17, and x equals -2 minus the square root of 17. So we wound up with 4 solutions in this scenario. All right. Let's do the next one. Just tons of fun here. Like I said, hopefully by now the U substitution just jumps out of the page at you, or jumps off the screen in this case for you. My U substitution here is going to be the 12x squared plus x. So that when I do my U sub here, it looks like U squared minus 14U plus 13, equals 0. Now, this is an easily factorable one, which is nice. This should factor into -13 and -1, so that we can get that U equals 13 and U equals 1, which means we can go directly into our substitution here. 12x squared plus x equals 13, and 12x squared plus x equals 1. And then I can bring everything to one side. We'll start with this one on the left hand side, so I get 12x squared plus x minus 13 equals 0. Now we can sit here and we can try to factor this one. Like I said, if you need a review in factoring, you're going to have to go and YouTube a separate video for it, because that's prerequisite information at this point. So I can factor this into 12x plus 13 times x minus 1. You can double check that for me if you want. 12x and 12x, 12x squared, 12x and -1, and then 13 and x, subtract to give you a positive x, and then 13 times -1 is -13. Now, I can then set each of these terms equal to 0. I'm going to solve the one right here first. It's easy. One solution is x equals 1. The other solution, have to work out a little bit further. I've got 12x equals -13, so that x equals -13/12. There's solution number 2. Now I have to go back over to this other U sub equation, solve it and get everything on the other side so I can figure out what my other 2 solutions may be. Alright, here I have 12x squared plus x minus 1 equals 0. And I'm going to try to factor it as well. So if I were to factor this one, come on, pen. It's going to look like, no, this one's not going to be 12x. This is going to be the one where we split 3 and 4. Let me fix that. So I'm going to split it into a 3x and a 4x. That way I can get that 1x out of it. It's going to look like 4x minus 1 times 3x plus 1 equals 0. If it were me and I were trying to write this out and I wasn't that great at factoring, especially not my mind, what I would do is I'd wind up doing this one by the factoring by grouping method that we taught in Math 108. Like I said, you can go look that back up. I actually have, I think, a video of that on my YouTube page. You have to search it a little bit about factoring by grouping. But once you get it factored here, the 4x minus 1 times 3x plus 1 equals 0, what we can go ahead and do, set each of them individually equal to 0. That way we can solve. Also keep in mind, if factoring is just not your thing, the quadratic equation works every time. So I can go directly from here and plug 12, 1, and -1 into the quadratic equation for my a, b, and my c, and I will get the same answers as I'm about to get from what I just did by factoring. Now, for the 4x minus 1 equals 0, it's going to simplify down to 4x equals 1, which simplifies down to x equals 1/4. So that's our third solution. And here the 3x plus 1 equals 0 will simplify down into 3x equals -1, so that x equals -1/3. And that is our fourth solution. So we have all 4 of our solutions available here. Oh, see, and you can see it work through here as well on the PowerPoint slide if you needed to. Now, let's look at example 5. Example 5 gets a little different here. Here we're looking at y equals 2/3 plus y, or plus 5y to the 1/3 plus 6 equals 0. All right, so my u sub here is going to look like y equals, or sorry, y to the 1/3. Okay, so this will allow me to write the equation as u squared plus 5u plus 6 equals 0, which I can then come in and factor, right, into, that's what, u plus 3 and u plus 2. Because 3 times 2 is 6 and 3 plus 2 is 5. Those are going to split into two equations that look like u plus 3 equals 0 and u plus 2 equals 0, so that I can replace u with y to the 1/3. And then I can go about solving. All right, well here I have y to the 1/3 equals -3. Now, let's think about this in terms of how we would attack this if this was a square root. Okay, because essentially y to the 1/3 is just the third root of y. Now, how would I get rid of that third root? Well, I should just be able to raise it to a power of a third, and that should kind of cancel it out, right? Because that's the same thing as 1 times 3 here. 3 divided by 3 is 1, which would just render me a regular y. So I just need to cube both sides. So y to the 1/3 cubed equals -3 cubed. So that should simplify down to y equals, what's -3 cubed? Well, that's -3 times -3 times -3. Well, -3 times -3 is +9. +9 times -3 is -27. That is one solution. Let's try this other solution here. Well, here, it's going to be y to the 1/3 equals -2. Once again, I can just cube both sides. Well, let's look at 2 cubed, -2 cubed, excuse me. -2 times -2 is +4 times -2 is -8. So I have two solutions here. I have y equals -27 and y equals -8. Now this pretty much completes what we're doing for this lecture. What I encourage you to do before you call it quits and try your homework is I encourage you to start back at the beginning of this PowerPoint without me talking through it and lecturing through it, and you to try to go through it by yourself using the U subs instead of just watching me do it. And then if you're having trouble, you can come back and check your steps with some of the stuff that I did. Because I assumed that you were 100% up on a knowledge of factoring, of simplification steps, so that I was able to go very fast, because that's where you should be with the course. But I know that some individuals struggle with some topics more than others, and this topic of factoring and simplification tends to be one of those topics. So I don't expect you to be able to go as fast as a pace as I'm going. So I need you to go back and check to make sure that you not only understand the concept that we're doing here with the U substitution. Usually people understand that pretty well. Like, okay, I can see pretty visually by the end of this what the U is supposed to be. But go back and refresh to make sure that you can actually do the algebraic simplification steps and the algebraic factoring steps or quadratic equation steps that you're going to need in order to build on that knowledge with the U substitution. Because substituting U is really the easy part here once you see how it works. But you need to make sure you can work on that prerequisite knowledge to be able to finish out the equation and see where it goes. So please, please, please go back and practice and make sure you can do this on your own. And don't take for granted that you were able to just sit through and watch me do it. If you have any questions, send me an email. Be sure to try your homework, and I'll see y'all next time.